In a world of constant shortages, one quantity remains in abundant supply. It's called entropy.
The science of thermodynamics is based on four fundamental postulates or axioms which are called the four laws of thermodynamics. Of these four laws, the second law was discovered first, and the first law was discovered second, and the third to be discovered was called the zeroth law, and the fourth law is called the third law. Now, all of that makes perfect sense because thermodynamics is the most implacably logical of all the sciences. Let me tell you briefly what those four laws are. The zeroth law just says that the idea of temperature makes sense. The first law is the conservation of energy. The second law is the entropy principle. And the third law says that there is a temperature so low that it can never be reached. From these four laws, people have deduced not only the properties of matter, but the ultimate fate of the universe itself. Now, if we're going to get anywhere on that today, we had better get started.
Chalky's Billiard Academy, an inner sanctum of sorts, where beyond the harsh glare of the limelight, celebrities of sport, dandies of high society, and captains of industry gather to pursue a common interest. One may wonder how these gentlemen manage to keep their names out of the newspapers, to say nothing of the learned journals. And the casual observer may ask, what are nice guys like these doing in a place like this? But to those in the know, their purpose is obvious: to investigate the laws of thermodynamics. But why Chalkies? Partly, of course, it's the ambiance, which is the last word in understated elegance. But that goes without saying. Mostly, it's the equipment, the specially called for apparatus that in the interests of science, Chalkies always seems to have on hand. Even now, two distinguished scientists hold beakers.
Due to mature subject matter, the following experiment should not be viewed, much less conducted, without parental consent.
Held with the greatest care, each beaker contains a small amount of experimental fluid, which unfortunately is an acquired taste. However, before things began to get out of hand, the fluid was poured into the beakers at a temperature of 295 kelvins, and with scientific precision, several geometrical cubes of crystalline H2O were added. Initial temperature of the crystals, 273 kelvins. As time passes, heat from the warm fluid flows into the cubes, but the ice fails to warm up in response. The cubes don't melt at once, which stirs up a scientific controversy. And, of course, this calls for more tests. During 126 experiments, but who's counting, none of the Chalky scientists can find a single instance of a warm ice cube. But on the other hand, they have found a dilution of the properties of the experimental fluid. The ice, staying at a constant temperature of 273 kelvins, melts into liquid water as heat flows into it. What accounts for this strange behavior in Chalky, or for that matter, everywhere else in the world? Eventually, of course, ice melts. But along the way, in its solid state, why won't it warm up? In any case, in the end, the ice, the experimental fluid, and in fact everything else, reaches a state of equilibrium. Somewhere, at least in theory, there's a heavenly state called equilibrium. But in the real world, equilibrium is hard to find. On a Polynesian isle, the planet cranks up and liquid fire bubbles from down below. And in the polar center of the Arctic Ocean, the world's original ice machine works around the clock. In the deep and darkest heart of Equatoria, the sun sears a savanna with a relentless regularity. And a shout away, liquid thunders to the rocks below.